Node.js is designed to handle a large number of concurrent connections, making it well-suited for real-time and high-traffic applications. While many other technologies use multiple threads to handle requests, Node.js uses a single thread to handle concurrent requests. So how come Node.js supports high-traffic applications? It's like a restaurant having one waiter. The waiter takes multiple orders, but there are still cooks and managers to deliver the food. Even though Node.js has a single-thread architecture, it uses the system kernel and thread pool to offload tasks. So you can view the event loop as the waiter taking orders, and the thread pool and the system kernel as the cooks and managers helping deliver the order behind the scenes. So whenever there is a request, Node.js doesn't assign a thread for every request. Instead, it uses an event-driven model to process requests in a single thread. So here in the graphics, requests pass through the event loop, and the event loop executes what can be done immediately and offloads time-consuming tasks. So when the thread pool or the system kernel finishes the task, it notifies the event loop, and the result will be passed through the callback. We'll talk more about the thread pool system kernel and the event loop, but for now, let's take a look at an example. This is a simple example. To read a file, the event loop registers the read file to be executed on the thread pool, and it continues to execute other tasks without blocking the thread and wasting the CPU cycles. So it doesn't wait until the read file is done. It immediately calls the more work function, and it then executes the read file callback when the result is ready. Okay, so we've only discussed a little bit about how Node.js processes the code behind the scenes. The event loop, system kernel, and thread pool are critical to understanding how Node.js works behind the scenes. So in this video, I'll be explaining about those three critical components, and we'll see an example of how the codes we write are executed in Node.js. So Node.js is designed to be non-blocking, which means it doesn't wait for certain tasks to execute the next line of statements. So how does Node.js achieve non-blocking and scalable applications? So Node.js has an infinite loop designed to run your code called the event loop. It's basically what allows Node.js to be asynchronous and non-blocking. It constantly loops to check for events and execute what can be executed immediately, and it delegates time-intensive tasks. So Node.js has two types of threads. The first one is the main thread, which is the event loop, and the second one is a group of worker threads called thread pool. As I tried to explain in the previous video, certain codes are executed in the event loop, and there is also a priority in order to how it gets executed. What do I mean by certain codes? Codes like initialization, assignments, and callbacks, including any JavaScript codes such as doing a for loop, a while loop, or things like that gets executed on the event loop, and it's not offloaded to the thread pool or the system kernel. So you can think of the event loop like a middleman between your code and the other Node.js component. And the way it achieves non-blocking behavior is by offloading time-taking tasks to the thread pool and interacting with the system kernel while focusing on listening to events, registering callbacks, and requiring modules, and doing normal JS codes. So the operating system kernel is the core part of the operating system. It's responsible for managing hardware resources, system process, and various low-level operations. It acts as an intermediary between an application, Node.js in this case, and the hardware. When Node.js needs to perform system-level operations, like network communication or interacting with the hardware, it doesn't handle this operation directly. Instead, it makes system calls to the underlying operating system kernel. Okay, so now we have a clear understanding of the underlying Node.js components. Let's take a look at an example to understand this further. So most of the things you see here are covered in the previous section, except for the setImmediate. So I created an HTTP server, and inside it, it executes two things. The first is scheduling a task with setImmediate, And setImmediate is used to schedule a task in the next iteration of the event loop. It's used when you don't want to immediately call a certain function. Let's say you have a bulky task and you want to make it asynchronous to give a priority to the other operations. So next up, it reads a file asynchronously, meaning it doesn't block anything. So every code you see here is non-blocking. And finally, the server listens to port 3000 and it listens to the close event. So this kind of mimics a real-world example where we have a server, and when a request is sent, there are certain things we want to execute, like reading the file or other things. So given this code, let's go a little deeper and see how Node.js executes it. When we first start the application, the event loop will start to run. It first takes this code and executes it because variable assignment and require are executed on the event loop itself. Then it takes the http.create server and it assigns the system kernel to handle it. So the http.create server is a very abstracted function, and behind the scene, there is a lot of socket creation and management. The system kernel provides the necessary system calls and infrastructure to create, manage, and use sockets for network communication. So the event loop doesn't do this by itself, except by initiating system calls to the operating system and listening to the events. So, for example, notifications or events when an operation is completed for fails. The system kernel has different mechanisms for different operating systems. For example, there's a mechanism like epoll for Linux and IOCP for Windows. They're useful to monitor file descriptors corresponding to network sockets. And since the HTTP server uses sockets behind the scene, the system kernel is responsible for taking care of that. It doesn't end here. The event loop needs to queue the callback of the HTTP server, and then it executes server.listen and server.onClose and registers their callbacks. So when the system kernel notifies the event loop that it's done, the event loop will execute the registered callback for server.listen. So the callback of the create server runs whenever there's a request. So inside it, we have setImmediate and read file. How does Node.js process those two? So in this example, the event loop will assign the read file to one of those thread pools, and it queues a callback. The event loop does not wait till the read file finishes. It immediately executes the callback of setImmediate. Node.js uses a worker pool, also known as a thread pool, to handle expensive tasks. It usually consists of 4 threads, and when Node.js assigns tasks to one of the 4 threads, it means that it will be managed independently by the operating system scheduler, and a resource will be assigned to it. You can think of it like hiring people. You can assign some time-intensive tasks while you focus on overseeing things. For example, when reading a file, the event loop assigns one of the thread pools to do the actual file reading, and that way it will have time to do other tasks. Here, I have an HTTP server reading from a file address.json, which is pretty big, and if it goes well, it will return the data. If not, error occurred will be returned. Let's run and see it on a browser. It's returning a big chunk of data, and I will use load test to test the server's performance. Okay, let's open a new terminal to run the load test commands. So I have already installed it, but if you haven't, you can do npm install load test and -g to install it globally. Okay, so let's send a request and see how it responds. So load test and pass the URL that is being tested, that is localhost 3000, and add -c, which is the number of the requests that should be concurrent, and -n is for the number of requests to send. It's sending requests. It usually takes time, but I'm going to make it fast so that you don't have to wait. So it took almost 50 seconds to finish. And the latency is 9,496 milliseconds. Now I will increase the thread pool size and run the test again. Okay, let's first require the OS module. Const OS equals to require and pass the OS module. And to increase the thread pool size, I need to update the UV thread pool size. So let me assign the process.env.uv underscore thread pool underscore size to the number of CPUs. To get the number of CPUs on my PC, let me use the os.cpus.length. So my CPU cores are 12, and the default thread pool size is 4. So this will increase the thread pool size by 8. And please don't exceed the CPU length because that's the maximum it can simultaneously do tasks. And doing so might also degrade the performance. Let's clean up the terminal and run it again and see what we get. So it's sending the requests one by one. Okay, and here we have the result. And let's see the time difference. So we were able to improve the time it took by 5 seconds, and the latency is also improved. So we've seen how to increase the thread pool size by changing the UV thread pool size, and it improved the time it took. But does this work every time? Well, no. There are certain activities the thread pool is responsible for. Those operations that are executed on the thread pool are the lookup and lookup service functions of the DNS module, all file system APIs except for an fs.watcher, and synchronous ones are executed on the thread pool. Crypto functions and all zlib APIs, except those that are synchronous, are executed on the thread pool. zlib APIs are used for compressing a file, and increasing the thread pool size can help improve performance if you are utilizing one of the listed functions. Node.js is built on several dependencies. In this video, we are interested to talk about one of the most important dependencies, libuv. In the previous video, we talked about the event loop and thread pool. Libuv is the library behind all this. It provides a mechanism to handle file system, network, and child processes, including thread pool and event loop. When we, for example, use the fs module, we see the very abstract version of it. But Node.js is using libuv behind the scenes to read the file by interacting with the operating system. If you navigate to the Node.js source code, you will see a folder called src. It contains a C++ code that uses libuv and v8 to implement several functions. You will also find a lib folder containing JavaScript implementations of the modules and functions we usually use. So we'll track down a read file function that uses libuv. Open your terminal and type node, and then you will do fs.readFile.toString to see fs read file implementation. This function is the same as what we will find in the lib folder. Now let's head to the lib folder and find fs.js. Let me scroll down and look for fs.js. So the file contains the fs module code, and you will also find the read file function here. Let me search for the read file and let me zoom out of it. So on line 375, you can see that it requires the read file context from the internal fs. Now let's go back to the lib folder and click on this internal folder. Let's also scroll down a bit and find the fs directory. You can see the read file context, which is the file that was imported on the fs.js file. Let me scroll down to the bottom, and here is the read file context class. If you scroll up, you will find a require statement to the C++ codes. And as you can see, it's importing these three C++ functions from the source directory. So the JavaScript in this file makes a call to the C++ functions inside the src folder, and the internal binding function is used to import a C++ file, just like the require function. And if you head to the source folder, you'll see those functions. So let me first go to the root folder by clicking at Node, and then click on src directory. Let me look for nodefile.cc, which is the file that contains the imported C++ functions. And if you simply search for one of those functions, for example, close, you will see it here. So it's in the source directory where the actual OS interaction happens. And if you notice something that starts with UV, you'll know that it's utilizing libuv variables or functions. So to wrap it up, your Node.js code uses functions and modules from the lib folder, which is written in JavaScript, and the functions inside the lib folder uses functions from the source folder, which in turn uses libuv and V8. While V8 is a JavaScript engine used to execute JS codes, libuv is a C library used to provide asynchronous and non-blocking functionalities like file system, event loop, thread pool, socket, and signal handling. Pretty much everything. When we talk about building a high-performing application in Node.js, it sometimes is the right use of event loop and thread pool. We mentioned several times the event loop uses a single thread, and if it gets blocked or spends a lot of time on a single operation, other incoming requests will not get a chance to be served. So the best way to write performance-optimized code is by writing asynchronous code that doesn't block the event loop. So how do we make sure we don't block the event loop? So the first tip is to have a single responsibility per API. Instead of doing a bunch of tasks in a single request, separate into multiple APIs, which can finish quickly. This not only guarantees a fast response, but also helps us to maintain it easily. The second approach is to keep a constant number of time complexity. Let's say your application is doing the sum of n numbers. As n grows, the time it takes also grows linearly. If one of your users wants to compute the sum of 1 million numbers, and the other user wants to do the sum of 10 numbers, it creates a huge variation of time to process each of the client requests. So the event loop can be blocked by processing one user's request. Let's see this in action. So I will create a HTTP server that computes the sum of n numbers, and I will use the HTTP module. Const HTTP equals to require, and pass the HTTP module. And let's create the HTTP server using http.createServer, and it takes a callback function with request and response. So let's assign it to a variable called server. Now let me listen to the server using .listen and pass a port number of 3000 and a callback function that logs server listening on port 3000. So I'll just paste a for loop here, and it's simply adding I to the sum. Let me also add response.end to return the sum. Now let me import the query string and URL module to parse the query parameter. So const query string equals to require, and pass the query module. We also need to import the URL module So I have already explained query string and URL modules in the second section, so you can just go back and watch it if needed. Just above the for loop, let me create a query variable and I will parse the URL by using url.parse method and passing the request URL and .query. So this will pass the URL, meaning it will create an object containing the query parameter. So const n equals to query string and dot parse and pass the query and fetch n out of it. Let me run it now. Let me head to my browser and add localhost colon 3000, then question mark n equals to 10. Let's see the issue. So I forgot to convert this to a number. And I need to define the sum. Let me also define the sum variable and give it a value of 0. So let's send the request again. So it's throwing an error again. Let's see what it is about. It is saying it must be a type of string. So let me change the response to string. So let's replace this with string and pass the sum value. And let's run and test it once again. Okay, it's now working. I will pass it a big number and see how it responds. Let me pass 1000 here and run it. Let me also create a new tab and pass to it a very large number. Okay, so yeah, it's loading heavily. And let's send another request with a small number. As you can see, it couldn't even respond to one. This is because arithmetic operations are executed on the event loop, just like any JS code. And when you pass a huge number, the event loop gets blocked processing that single request, and other requests get blocked. There are different approaches to avoid that, and the first is by validating your input to only allow it to a certain range. So I'll limit the number that can be passed by adding an if statement and checking if n is greater than 1,000,000. Return a response with an error message. So now let me send a request with 1,000 numbers. Let me change the value to a larger number and test. And yeah, the request is rejected, as you can see. But what if you need to compute for high values or you have time-taking operations? There are also different ways to deal with that, and we'll see it in the next video. In the previous video, we saw a heavy calculation that blocked the event loop, and we improved it by validating the input. In this video, we will see a different way of writing non-blocking code with setImmediate. The setImmediate function is used to run a code after the next iteration of the event loop, which means the event loop prioritizes what can run immediately, such as initialization, assignment, and registering asynchronous I/O before calling the setImmediate function. Let's see an example using the setImmediate function. First, let's define a variable, const message equals to hello, and let me console log it. Here, let me call the setImmediate function and pass a callback function, which then console log setImmediate. So let me run and see the output. So the initialization and console log statements are being executed before the setImmediate. Let's also add a for loop and see which one runs first. You would think the for loop might take time, but it is the same output as before. So let me console log I and run the code. 3 is just enough for now. So again, the setImmediate is logged at the very bottom, which tells us that JavaScript code runs first before the setImmediate gets executed. Now, let's improve the sum app from the previous video. And the way we do that is by creating a new function that uses setImmediate to add each I value to the sum. Since I'm going to create a new function, we don't need this. And down here, let me create a new function, findSum. So it takes a number n and a callback function that's going to be called with the sum result. And let me first create a sum variable with a 0 value. Let me also create an inner function add that takes I and a callback function, so the inner function will add I to the sum defined in the outer function, and it will call the callback function with the result once it's done. Here, we need to increment the value of the sum by I, and just outside of the inner function, we need to call the add function with I equal to 1 and sum callback. Now, let's check if I is equal to n, and if it does, it means that it's done adding the sum, so let's call the callback with the sum. And let's not forget to return it. So otherwise, it calls itself like a recursion to add the next I to the sum. So I will use setImmediate to call the function add. Now, let me call setImmediate and pass add dot bind and pass null first and I plus 1 and finally the callback. All right, let me now explain the code. Here, I used a closure function, so it will keep a new sum variable whenever it's called. Let's say n is equal to 3. The add function will be called immediately with I equal to 1. So it will add I to the sum and check if I is equal to n. 1 is not equal to 3, so it will call the setImmediate function. So when we call the add function inside the setImmediate, it still runs on the event loop, but it will give a turn to run other codes instead of blocking. It simply makes it asynchronous or non-blocking. So there's a difference between making the code non-blocking and fast. While it prevents any blocking of the event loop, it will not make it faster. When a function is called with bind, it returns the copy of the function instead of calling it immediately. So it would be something like this. So the first argument of bind is the context or the object we're using to run the function, which is null since we don't want to attach it to any object. And the next is the add function arguments. When the function is called next time, I is incremented by 1, and it will again add it to the sum. Then it will repeat this until I is equal to n. When finally I is equal to n, it will call the callback as a way of returning the sum. Now, let's call the findSum function and run it. So findSum and pass n as the first argument and also the callback function. So finally, we need to respond to the request with a simple message and the sum value. So it would print the sum, then the value of the sum. Let's clean up the terminal and run the file. And then let's send a request and see what we get. So there's unexpected error. Let's go back to VS Code and see what the issue is. Okay, so it says the sum is not defined. Let me scroll up a bit and I should remove this. I can now restart the server and send the request again. All right, let's refresh, and this time we got the sum result as expected. Let me also add one simple message before the sum result. So it will first say your request is being processed, and when the sum is ready, the sum result will be displayed. Let me also add a line break here, and then resend the request again. Okay, we got a message with the sum. Let me also run it for a big number, and it is loading. But we can send other requests. So as you can see, when I send other requests, it doesn't block the other requests as before. What setImmediate is doing here is not making the sum function fast. It will even be slower. But it's making the function non-blocking so that the other requests or operations can run without being blocked. The best scenario to use setImmediate would be to call a function that doesn't need to be executed and returned right away. Or it can also be used to delay execution of a function so that we can make sure the operation that needs to be fulfilled first is given a priority. For example, in the Node.js source code for the HTTP module, setImmediate is used to delay the execution of the parser.close function. Since the other code needs to run first before closing the parser, it's being called with setImmediate. So back to the sum function. What if we need to return it right away and in a non-blocking manner? Let's see it in the next video. Worker threads are useful for performing CPU-intensive JavaScript operations in parallel. It makes it faster and more efficient by delegating a separate thread for it. In the previous videos, the sum was being executed in the event loop, which means on the main thread, and by using worker threads, we will create a separate thread, and we're going to move the sum function from the main thread to the separate thread that I will create. This will make the application not only non-blocking, but also faster. All right, let's get to the code now. First, let me get rid of the implementation of the sum function, and we don't need the callback. Let me remove this also. So there is a worker thread module in Node.js that is used to create a new thread. So let me import it. I am going to use the object destructuring syntax to import the worker and require the worker thread module. So the function now will return a promise that initiates the worker. Let me pass it to a callback function that has resolve and reject parameters. Okay, here, let me create a new worker thread using new worker, and it takes two arguments, a path to a script that we want to execute, and a data we want to pass to the script, so we can pass the data using the worker data. Now, let's listen to the incoming data using worker.onMessage and pass a callback function with a data argument, which is called when the worker runs successfully. We want to resolve the promise once the data comes from the script. So let me also add the error listener by adding dot on error. And if there's an error, we want to reject the promise. I'll also explain this later, but for now, let me create the script file that the worker will execute. Let's create a directory and give it a name of workers. And let me add a file called summation.js. Here, I will just add the sum for loop. So it ranges from 0 to n, and let me replace this with sum is equals to sum plus I. Let's first create and initialize the sum. So now let's import two things, the worker data and the parent port. Const, and let me leave an empty object and require worker threads. Now let me put worker data and parent port here. So the data is sent through the worker data, and we can fetch it here using workerdata.n. So the parent port is used to send messages to the parent that created the worker, which is in index.js. So let's call parent port dot post message and pass the sum, and this will send the sum back to index.js once it finishes the operation. Now let's get back to index.js and change the path. So let's add .workers/summation.js. Let me call the findSum function here and pass n, and let me also assign it to a sum variable and add a wait. That means I need to add the async keyword as well. Okay, and finally, we need to respond to the request by sending the sum result. So let me explain what I did here. The function returns a promise that will be resolved when the sum result is ready and is rejected in case of an error. So after that worker.onMessage will listen to incoming data, which is the sum result. So when creating a new worker, it takes a path to the script that's going to be executed and worker data, which is used to send data to the script. As soon as any worker is created, summation.js will start to run. So after that, worker.onMessage will listen to incoming data, which is the sum result. Now let me run it and see what we get. So the server's running, and let me head to the browser and send a request for a sum of 10 numbers. And let me add another request for a sum of a very large number. And let me add one more also with a query of 100. Okay, so it's non-blocking and it's also very fast. This can be a better approach when you do complicated CPU-intensive tasks. So we can also replace this with just the resolve. So instead of running everything on the main thread, we created a new thread or worker to offload CPU-intensive tasks that make it efficient, faster, and non-blocking.
In one of the previous videos, we mentioned that writing high-performing application is simply the right use of event loop and thread pool. And we talked about non-blocking code, and I shared 2 best practices. In this video, we will continue with the 3rd best practice. Synchronous functions are blocking by nature, and you should be careful when using them on your server. These functions usually end with sync, and you can use the callback or promise version of these functions to write asynchronous codes. The 4th tip is to minimize the use of JSON.parse and JSON.stringify on large data. That might be a bit surprising, and you're probably using these 2 functions many times. While these 2 functions are fine for small to medium data, the problem starts when your input grows. It takes a huge time, and it could potentially block the event loop. If your application takes in a process data from a user, you should be cautious about the size it takes. Here, I have a code that parses a JSON file and measures the time it takes. And here, I have a big JSON file, which is about 185 megabytes. Okay, let's go back to index.js and run the code. A bit of waiting, and it took about 2 seconds. So this can slow down your server when you have many requests and also a bigger file. Let me also add a simple console log here to see how the code is blocking. Let's run it. So the blocks of code is being printed last because it is being blocked by the parsing. Part of the reason why this takes so long and is also blocking is because it's reading and parsing the whole data. So I'll show you an asynchronous way of doing this by using stream JSON. Stream JSON parses your JSON chunk by chunk instead of reading the whole thing. Let me scroll to the bottom and find the code. So to get us started, I will copy and paste this and remove what I don't need. So let's simplify the code. For example, we don't need the pipeline. Let me minimize the size of the terminal. And there are still some things to clean up. So let me scroll up a bit and remove this function as we don't need compression for now. We also don't need the ignore function import. This should be stream arrays because we're going to stream an array of values. And it should be imported from the streamers/stream array. We don't need this function either. So let me change the file name here to the citybig.json file. So the JSON data has two properties, type and features. And I only want features, which is an array of data. So the pick function will only pick and return the features. And let me remove this. Now, let me replace stream values with stream arrays. And here, we don't need the counter variables. So pipeline.onData is listening to a stream of data. And let me console log the data we get from the stream, and the function should take the data as an argument. Now let's visualize how the code works. So the data will go through every function in the chain, and after it finishes, it will return a stream. So the chain function takes an array of functions and returns a stream of data. The first argument is fs.createReadStream, which is used to generate a stream from a file. The second is a parser, which is used to parse the JSON. And the third is a pick function, which is used to pick only certain properties from the JSON data. The fourth function takes an array and produces a stream of its value. You can also add more functions like ignore if you want to remove some attributes. Let me run it and see if the code works as expected. Okay, so I forgot to install the stream JSON package. Let me copy the command from here and paste it on my terminal. So it has started the installation, as you can see. Now I need to rerun the file and see the change. It says stream array is not a function. I think I misnamed the stream array, and this needs to be corrected to array instead of arrays. The import also should be from stream array. So as you can see, it's continuously streaming the data. For example, let's filter by the odd-even property, which has a value of e, if it's even, and we will return only the even ones. So let me copy this and head back to the index.js. Now let's check if the data.value.properties, and let's take the property name from the JSON file. Let me scroll and see if I can find it. Okay, so let me copy it and add .odd even here. And if only it is equal to e, I will return the data. Let's rerun the file. So we got only the even data, so the data filtering is working as expected. One more thing I want to do is check how the code is non-blocking. So let me add a simple console log at the end of the code. And if it runs first, it means it's non-blocking. So let me comment this out first and run the code. So JSON stream can be a great approach when dealing with big JSON data extensively, as it makes the code non-blocking and more performant.